Ladies and gentlemen, what's up? Here we go. First video of section 7. I'm going to do 2 videos, but here's the first one. We're going to talk about how do you solve and graph absolute value equations. And oh yeah, we're going to talk about this word right here, absolute value, first. So let's dive into this and see what comes out. And you're going to take notes somewhere in your notebook. I don't have a graphic organizer for you. But take some detailed notes on this. Go back and study it a bunch of times because there's some great information in here. Well, let's rock and roll. So question is this. You have 2 different symbols here, and you see on the screen it says, what's the diff? What's the diff? What's the difference between this symbol right there, these 2 lines, and these parentheses? So for example, if I happen to have, I don't know, this symbol and a -4, and then that guy, and I asked you what it equaled, and then I said, well, let's put this guy in parentheses like that. And I ask you, is there even a difference? Like, does it even matter? And I hope you're going to say, yeah, dude, because these things right here, the straight lines, represent something called absolute value, which is completely different than just straight up parentheses that say, hey, let's group this stuff together. So if I had like the absolute value of like -4x plus 7, absolute value, and I had parentheses -4x plus 7, that is completely different. This absolute value is asking something totally different than just parentheses. So let's talk about what the difference is. Well, we just talked about the difference. Let me give you the definition of what absolute value is. So absolute value to me, you see here, and this needs to go for sure in your notes, it is the distance, absolute value is the distance, that's a key word right, the distance, that a particular number or a variable or an expression or all kinds of things, but whatever's within the absolute value symbol, so whatever in here, in there, doesn't matter. It's asking you how far is that thing from 0 on the number line. So for example, if I put -2 here like this, and it says, excuse me, absolute value of -2, it's asking you, hey, how far is -2 from 0? Well, the distance, as you guys know, distance is always positive, so that would be 2 units from 0. That's what it's asking you. So if I did this, what if I put in, I don't know, 5? Absolute value of 5. Well, you go look at 5 and say, right there's 5. How far is 5 from 0 on the number line? It is 1, 2, 3, 4, 5 units. So that's the answer, 5. So it doesn't matter what it is. If I did the negative of 1/3, gross, but -1/3 happens to be a distance from 0 of positive 1/3. Yoo-hoo! Thank goodness that went positive. Anyways, so that's the distance. What if I do this? How about this, the absolute value of negative house? How about that? I wonder what that would be. Oh, the distance that this negative house is from 0 on the number line, if this happened to be a number line of houses, whatever, it would be a positive house. So it's asking how far is something from 0 on the number line. That is extremely important to understand. How far is this from 0? 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 You sick of me saying that yet? I'm kind of sick of saying it. So that's what it's saying. How far is it from 0 on the number line? So let's apply it now to something different than the number in there, okay? Let me scoot this down. So here's the scoot. So now I have absolute value of x. Let's say I equal that, just making this up completely. Let's say I equal it to, I don't know, 5. Completely making it up. Now this is telling you guys something different. It's saying, hey, I have no idea what's in here, but I'm telling you I want it, and it needs to be a distance of 5 from 0 on the number line. So it's actually telling you the distance, whereas back here it was saying, hey, how far is it? This was asking how far it was. This is now saying in this question, it's saying, wait a minute, I'm actually telling you for a fact. This thing in here, whatever it is, has to be 5 from 0. So what's your answer? Well, if I'm down here and I'm on 0, I could be 5 units up here. 1, 2, 3, 4 up here. So let's say that this happens to be 5. It's not set to scale, but go with it. So if this is 5, so that guy right there would be 5 units from 0. If I went down here and say this x happened to be a -5, so there's my 2 possibilities. So either, if I have absolute value of x, and I'm saying I need it to be 5, either x is -5, or the other option, guys, is this. X is a +5. There's 2 options here. Because if you put -5 in for x, it is 5 units from 0. If I put 5 in for x, it is 5 units from 0. That's important. So let's go into a different example. So let's say now I want this to be, I don't know, make it up, 20, whoa, why is that not working? 29, whatever. So now I'm saying, okay, whatever's in here for x, that has to be a distance that's exactly 29. So my answer would be x is negative 29 or x is positive 29. Those are my two answers. Because this thing here can either be 29 down or negative 29 down, because that's the distance. Okay, let's roll into this though, which changes everything. So what if I now say, well, let's make this up. Let's say, instead of x, let's put an expression in there. So let's say 2x is in here. So this whole thing that's in here, let's say I want that to be 8 units away from 0 on the number line. I'm telling you specifically that's what I want it to be. So my equation, if I write it smaller, is this. The absolute value of 2x is equal to 8. So that means this thing right here, I should use a different color, hold on. That thing right there, I'll use green. So this thing right in here, that thing there has to be 8 units from 0. But you guys know from the last example, go back and watch it again if you need to, this thing in here then could be either 8 or this thing here, 2x, could be negative 8. So that distance, all of this, if this box was either an 8, great, then I have the absolute value of 8, that does equal 8. Or if I had the absolute value of negative 8, great, that equals that. So my two options for this expression are either it's equal to 8 or it's equal to negative 8. I got no other choice. It's those two options. So now all I have to do is just simply go through and solve this. So I get, divide that by 2, divide that by 2. So one of my options then apparently is that x equals a 4. Or my other option that would work is that if I divide this by 2, divide this by 2, you get x equals negative 4. So there would be your two options that would work. So I gave you a simple example here. Now let's actually roll over and let me show you. Don't roll over, that would be weird. It's like a dog. I'm not saying you need to roll over and bark like a dog. I'm just saying let's go to another example, and I'm actually going to show you the 3 steps that you need to write down, highlight, start, whatever. These are the 3 steps that you're going to use to solve every absolute value equation. Okay? So let's write this down. Let's do it. Here we go. So as you actually see, if you go back in the last example I did, here are the 3 steps. So as it says up here, what are my steps to successfully solving any absolute value equations. Now here's the thing. I don't know why it says graphing. I should probably take that out because we're not going to graph absolute value equations. Sorry, that's actually a typo. I'd take that out. We're going to be graphing absolute value inequalities on the next video. But in this one, we're just going to be solving absolute value equations. So forgive that. Here's your first step. It says step number 1, you need to isolate the absolute value. Now I have 2 stars here because you're typically not going to have to do this, but here's what that means. If you have an absolute value equation like this, and it has something at the beginning like, 5 plus this whole thing. If you're going to solve this properly, you have to isolate this absolute value thing before you do any step at all, which means you'd have to get rid of this 5 over here. Or maybe say, for example, it started as like 1/2 times the absolute value. You'd have to isolate the absolute value before you do anything else. You'd have to multiply this by 2, multiply that by 2, and rock and roll. But again, you're not going to have really any that's going to be like that in this particular section and beyond. However, I wanted to make sure you knew that. So really, there's only 2 steps. Here's what you do. Step number 2, which is really your first step that's going to happen, with this example right here that should be in your notes already. If it's not, pause it, put it in there. We're going to solve this absolute value equation. How do we do it? We're going to set up 2 equations, exactly like we just did in the previous examples. Go back and rewatch them if you not get it. But I need to make sure then that this thing right here, that thing right there, which is in the absolute value symbols, it has to be 15 units from 0. So I only have 2 options. That means this thing is either going to be negative 15 or it's going to be positive 15. I only have 2 options. This thing in the parentheses, that box, is either going to be negative 15 to make the distance 15, or it's going to be positive 15 to make the distance 15. So I have 2 scenarios. Either this is negative 15 or that is positive 15. So that is step number 1 really that you're going to be doing. That one right there, baby. So then what do we do? Well, now, ladies and gentlemen, you just pretty much have two simple equations that you use your graphic organizer if you need to and solve it. So let's do that real quick and we'll be done. So that means I'll do this. Over here, I have to add a 3 to this one, add a 3 to this one. So that means I get, this is gone, theta. So I'm left with 6x equals negative 12. And then I divide this by 6. It's the same steps. It's no different than you've been doing in Algebra 1. Even this year, what we solved so far in Algebra 2. So there is one of your possible solutions. X equals negative 2. The other one over here, do the same thing. Add 3, means you get 6x. And this cancels. Equals 18. Beautiful. Divide by 6, divide by 6. So here is your other particular possibility for x. And if you put negative 2 in there, or if you put 3 in there, that's going to give you either this scenario or this scenario. If you don't believe me, plug it in. Negative 2 plugged in there gives you negative 12. Minus 3 gives you negative 15. So check. That would be a true equation. If you put 3 in there, that would give you positive 18. Minus 3 gives you positive 15. And check. That would work. So that's what you're doing. You're solving for x to see which one of these is actually going to make the equation true. But you're going to have two solutions. So, if you want to write this down as a little addendum, a little star next to it, you will have two solutions to an absolute value equation. Is that 100% of the time? No, but I tell you what, if you don't, you probably did something wrong, and you might want to ask and check again. Okay? So here's your checkpoint question. At the end of this, you're going to do this question down at the Google form, and I want you to answer this question right there. So I want you to take that one, and I want you to solve it. Not graph. This again, I don't know why it's up there. Do not graph. See ya. So take this one and solve it. And when you put your answer in your checkpoint question of Google form, you better put both answers. So put x equals whatever number, and then put x equals your other number. You're going to have two solutions as you just saw. So good luck. Excited for you. This is awesome stuff because it leads into the next stuff when we talk about absolute value inequalities. But let's master this first, and I'll see you in class when we practice these. Have a great one. Later.